In section 3.3, we're going to continue talking about properties of logs, but we're going to expand on those properties a little bit. Now remember what I've told you before. A log is an exponent. When I ask you log base 2 of 32 equals what? What I'm technically asking you here is 2 to what power equals 32? This answer right here is an exponent. That's what it's asking you for. Saying how many times, that's the exponent, do I multiply 2 by itself to get to 32? The answer here is 5. So, like I've been preaching, if you know your exponent rules, you know your log rules. And that same thing is going to be true today. As we know, if we are multiplying exponents, so if we have x to the third times x to the fourth, then we keep the base and we add the exponents. Well, we can use this property to help us simplify log expressions. Now, these properties work in both directions. So instead of an equal sign in between the properties, I'm going to write an arrow. So if we have log base b of m times n, okay? Log base b of m times n. When I multiply with exponents, these are exponents, I actually add the exponents. So what you can end up doing here then is you can, what we call expand this, log base b of m, since it's multiplication, it's going to change to addition, log base b of n. And this can go in either direction. So you can start with 2 logs that you're adding, notice the bases have to be the same, and you can condense it, change it to multiplication, or you can start with multiplication and what we say expand it, change it to addition. So an example of this using actual numbers here would be if we were going to expand, that means we're going in this direction, then we would have log of 7 of, 3x. After the log, we have a multiplication. So when we want to expand that, we want to go from 1 log to many. So we're going to have log of 7 of 3 plus log of 7 of x. It seems a little bit silly, I know, because you're like, why would you want to make something that looked so nice and condensed and expand it out like this? And to be honest with you, we usually don't use it in that way. Usually we go, sorry about the jerking, usually we go in the other direction. And the condensing direction is very important to us because with the condensing direction here, what we want to do is we want to go from many logs down to 1, and we'll use that a lot when we end up solving log equations. I know you think you've solved log equations, but you really haven't yet. So here we're going to start with many logs. So let's do log of x plus log of y. So here we have log base 10 of x plus log base 10 of y. And when we condense, we go from numerous logs down to 1. So we're going to have 1 log. The addition is connected to multiplication. So instead of x plus y, we're going to have x times y. So that is both directions of that property. The other property that we know from our exponents is if you take x to the 7th and divide it by x to the 3rd, if our bases are the same, we keep that same base and we subtract the exponents. Well, that same thing is going to be true with our logs. So if we have log base b of m divided by n, what that's going to equal is log base b of m minus log base b of n. And again, these can go either direction, so I'm going to make this into an arrow that we can go either way. So if we were going to expand here, trying to keep this consistent with the example I used up here, let's change this to log base 7 of 3 over x. So that's going to go from 1 log to many, so log base 7 of 3 minus log base 7 of x. And if we were going to condense, again, keeping as much as I can these same examples up here, if I had log base x minus, sorry, not log base x, sorry, log of x minus log of y, we would go from many logs down to 1. So we'd have log of x over y. So these are two of the properties. As we know, when we multiply exponents, we add. There's the property in terms of logs. When we divide exponents, we subtract. There's the property in terms of logs. The last property that we have with exponents is if you have an exponent raised to an exponent. So x to the third to the fourth. What we do there is we multiply the exponents. So what this looks like in terms of logs is log base b of m raised to the n. And what that's going to become is we're going to take that exponent. Remember, log base b of m is already an exponent. So we have an exponent raised to an exponent. So we're going to end up multiplying that exponent by that log. So we have n times log base b of n. And again, we can go both directions here. So let's see if I can make those other ones work. I think I can. So if we're going to expand, we would have log base 7 of 3 to the x. So that exponent is going to come out in front of the log. Log base 7 of 3. And then if we were going to condense, let's see here, we would have x log y. So here we have an x times a log. So to condense that, instead of the exponent starting as an exponent and coming out in front, it's out in front, so it's going to become an exponent. So we have log y to the x. So I have a couple of examples that I'm going to show you. Today we're going to keep it super basic. On Monday, we'll get into some more advanced ones, and we'll also see how using these properties can help us with the evaluating that you did on the worksheet for 3-2. Okay, so a couple of examples here, and then I'll turn you loose. So the first thing we're going to do is we're going to expand. And whenever we are expanding, that means generally we're going from 1 log to many. And I will tell you, again, this is not the one that we use most often, okay? So here's our first one. And today's worksheet is going to have a mixture of some with just plain old numbers in them and others that have variables and numbers. So here's the first one. So we have log base 4 of 7 times 3. And again, you may be asking yourself, why didn't they just write this as log base 4 of 21? Because all they really want you to do here is just practice the properties. I know it would make more sense to write it as log base 4 of 21, but so they want us to rewrite this in its expanded form. So we want to go from 1 log to many. So we're going to have log base 4. And then what we're taking the log of has multiplication there. So that's going to change to addition. So we're going to take the first factor, 7, and then plus, changing that multiplication to addition. And then as soon as you change an operation, you have to introduce the log base 4 again. So we have log base 4 of 7 plus log base 4 of 3. And that's your final answer. You can't do anything else. Like I said, we're just practicing here, just the expanding, just those new properties we're talking about. So here is log 25 over 3. So again, we want to go from one log to many. So we look at the argument here of the log, which has a division in it. So we're going to change that division into a subtraction. And then of course, as soon as we changed that division into a subtraction, we had to introduce the log there again. And if you're feeling like I'm going too fast through these, you can always pause the video and try it on your own, and then come back and check your work. So now I'm introducing actually a couple different things. This says log base 7 of 3 times m to the second. So after the log, we have a multiplication and we have an exponent that we're going to change. We're going to get rid of the multiplication first. We save the exponents till the end. That's the order we have to go in. So log base 7 of 3, multiplication is going to become addition. Log base 7 of m to the second. And then we're not done yet because we have this m to the second. So we also have that power property that we can use. That power is going to come out in front of the log it belongs to. It doesn't come all the way out in front, just in front of the log it belongs to. So we have log base 7 of 3 plus 2 times log base 7 of m. Do not try and do 3 plus 2. You can't do that because this 2 belongs with this log and this 3 belongs with this log. So you can't combine those. All right. The natural log of the square root of x over 4. The natural log of the square root of x over 4. The rule that I've been preaching to you for a while now still holds true. As soon as you see a radical, immediately rewrite it as a rational exponent. So we're going to write this as x to the 1/2 power over 4. Because now when you see that x to the 1/2 power, you realize, oh, there's a property in there. So the argument of this log contains a division and a power. We're going to get rid of the division first. We save the powers till the end. So we have the natural log of x to the 1/2 minus the natural log of 4. And then that 1/2 is going to come out in front. If you would have left that as a square root, you wouldn't have seen that that was a power that needs to come out in front of that log. And there is your final answer. And I think I'm going to pause this and do a second video because otherwise they take forever to upload.